This lesson we're looking at blood alcohol content, or BAC. So your blood alcohol content is the amount of alcohol in your blood. And a person that has a BAC of 0.02 has 0.02 grams or 20 milligrams of alcohol per 100 millilitres of blood. So when we calculate our BAC, a standard drink contains 10 grams of alcohol, so a small glass of wine or a middy of beer. So we've got some formulas used for calculating a person's BAC, but they depend on some of the following things. So one of them is the mass of the person, or their weight. The second is the gender or the sex of the person. So it has said that men can hold more alcohol in their blood than what women can. The number of alcoholic drinks. And how quickly the drinks are consumed. Now, we've got some formulas for calculating the blood alcohol content, and it's different for a male and a female. So for a male, it is 10N minus 7.5H all over 6.8 M, and BAC for a female is 10N minus 7.5H, so that's the same, it's just that that's divided by 5.5 M. So N is the number of standard drinks, H is the number of hours, and M is your mass in kilograms. So we're going to compare two people, male and female. So Alicia and James were at a party for 4 hours. James had 5 standard drinks and weighs 70 kilos. Alicia had 4 standard drinks and weighs 55 kilos. So we want to know who had the lower blood alcohol content. So we'll set this up. We have James. Okay, so his BAC for a male. And if we think back to the formula just above, is 10N minus 7.5H all over 6.8 M. Now all we need to do is substitute in. So N was the number of hours that they were drinking, the number of drinks that were consumed, which is 5, minus 7.5, and H is your hours, so that was 4 hours. And it's all divided by 6.8 multiplied by how much he weighs, which was 70. So all of this needs to get put into our calculator. And if we put it in, it does come up as a fraction, but we can then press our decimal button and that changes to 0.04201 and so on, which is 0.042 blood alcohol content. Then if we look at Alicia, so we're taking our BAC for a female, which is almost the same formula, so it's still 10N minus 7.5H, just this time it's over 5.5 M. So 10 times the number of drinks, which was 4 in Alicia's case, minus 7.5 times 4 hours, all over 5.5 times her mass, which is 55. And if we put this into our calculator, we get 0.033057 and so on, which is 0.033. So if we were to look at the difference between those, we can say that Alicia has a lower BAC. So Alicia has the lower BAC in this instance. Now, if we continue looking at our blood alcohol content, we have some limitations for the formulas. So the BAC formulas used only give approximate blood alcohol content, as many other factors can also affect them. So that can be things like your health, if you have any underlying health conditions or medical conditions, the time taken for your liver to process your alcohol. And this can be different for each person. The type and size of your drink. So if you have a larger drink with more alcohol content, or if you don't make it as if it was one standard drink, there's obviously going to be more content in that. How fast you drink. So that means that the faster you drink, that's going to be the higher your BAC. And if you've eaten food, this helps to absorb the alcohol a lot quicker. So if you've eaten food, the alcohol is absorbed more slowly into your bloodstream, so it means that it doesn't affect you as quickly. So getting back to a BAC of 0, so a healthy liver can only break down one standard drink, which is per 10 gram of alcohol per hour. So once a person stops drinking alcohol, it can only reduce by between 0.015 and 0.02 per hour. So for a body that reduces the BAC by 0.015 per hour, the number of hours before reaching a BAC is worked out with this calculation. For a body that reduces by 0.02, it's the same, we just change the denominator. So if we're looking at our example, we're still using Alicia and James. We have Alicia and James, they're on their P plate, so they stopped drinking at 11:30 p.m. and waited until one of them had a BAC of 0 and could legally drive home. So who drove home and at what time? And what we're assuming here is that the BAC is reduced by 0.015 per hour. So your question will tell you that if necessary. So if we look at James, so his BAC was 0.042, and if it's decreasing at 0.015, we're getting 2.8, but I need to put that into our degrees and minutes. So 0.042 all over 0.015. So 2.8, if I press that DMS button, it turns it into our hours and minutes. So he will take 2 hours and 48 minutes to get a BAC of 0. Alicia, her BAC was 0.033, and if we're using the same decreasing, that is going to give me 2.2, which if I put that into our hours and minutes, so 0.033 over 0.015, and then hit my DMS button, that's 2 hours and 12 minutes. So 2 hours and 12 minutes. So if we look at that, we can see very clearly that Alicia will be able to drive home. So Alicia drove home, and I want to know at what time. So I need to calculate 2 hours and 12 minutes after 11:30. So that is going to take me, drove home, so 2 hours and 12 minutes later, and if I add that together, that gives me 1:42 a.m. So that's all of our calculations there. The last little bit we're going to look at is if we were to graph our BAC, so to see what is happening. So after drinking 5 standard drinks, Ben's BAC was 0.08. It decreases over time according to a linear function, which is b equals 0.08 minus 0.015h. So we're going to write these correct to 3 decimal places each time. So if we were to put this into our calculator, we would have 0.08 minus 0.015 times 0.5. So that is going to give me 0.073 to 2 decimal places. 1.5 would be 0.058. 2 is 0.05. 0.043, 0.035, 4 gives me 0.02, 0.013, and 0.005. So I've already worked out these calculations, but all you need to do is use your substitution to actually work those out. So it says graph the linear function on a number plane. Again, I've gone ahead and done that just to save a bit of time. But you can see this is where I started at 0.08, and as it decreases over time. You don't need to put every single time after drinking in. You can see if you look at the hours, that is where it becomes a little bit clearer to draw those points on your graph. So what is the gradient of the line, and what does it represent? So my gradient, if I think about my starting point, which is 0.073, I'm going to minus 0.08, so I'm just looking between my first 2 points here. So if I were to look back here, 0.073 and 0.08, and I'm going to divide it by what the difference is, which is half an hour, so 0.5 minus 0. What that is giving me, if I work that out, is negative 0.0075 over 0.5, which gives me negative 0.015. So this represents the rate at which Ben's BAC is decreasing per hour. And we can see that because it's a negative number, so we know therefore it's a decrease. So use the graph to find Ben's BAC after 2 hours and 45 minutes. So if I were to use a different colour on here, if I go to 2 hours and 45 minutes, so that's roughly here, and I draw a line up until I hit where my line is and across, roughly his BAC therefore is going to be, so you can just use your approximate, so approximately 0.38. Now the opposite is saying, okay, well if Ben's BAC is 0.02, I would go to where it's 0.02 BAC, go across until I hit my line and come down, and we've got that as a direct answer, which is roughly 4 hours. And the last thing I have to do is using the equation above, so that was B equals 0.08 minus 0.015H. We want to know what that is when it's equal to 0. So if we change that to 0, so 0.08 minus 0.015H, I'm going to solve my equation. So I'm going to subtract 0.08 to both sides of my equation. So that leaves me with negative 0.08 equals negative 0.015H. To get H on its own, I'm going to divide by negative 0.015. The two negatives will cancel each other out, and I'm going to be left with H equals 5.33. So repeating, if I put that into my calculator, if I have 0.08 divided by 0.015, and then I press my DMS button, that's 5 hours and 20 minutes. So 5 hours and 20 minutes is how long it's going to take for Ben's BAC to reach 0.